Hello, this is group 1 for physics 111. And the group members are Stephanie, Michaela, Amelia, Maya, and Magdalena. So general overview of the project. We started off by dropping a pumpkin and a coffee filter at the same time from the height of about 1.8 meters. And then we dropped the pumpkin again with a stack of 7 coffee filters. And we wanted to do this so that we could have different masses for the coffee filter, but to keep it less than the mass of the pumpkin so that we could compare it to the time of the pumpkin touching the floor. And why we wanted to do the project. So Galileo's law of free fall states that in the absence of air resistance, all bodies fall with the same acceleration, independent of their mass. With this project, we wanted to show how when air resistance is present, 2 objects will not land at the same time. This project allowed us to observe the difference in mass on an object in free fall by comparing a control, which is the pumpkin, and a varied one, which was tested at a lower mass.
So we learned that Aristotle stated that objects fall with velocities proportional to their weights, but Galileo stated and concluded that motion under the act of gravity has a constant acceleration. So therefore, the magnitude of the uniform acceleration in free fall is dependent of the weight of the object. And constant acceleration is defined as 9.8 meters. 9.8 meters per second squared. So it is said if objects have equal acceleration during free fall, if we drop 2 objects side to side, they reach the ground at the same time. This would be true if air resistance is not present. So for the first trial, we have 2 objects, a pumpkin stress ball and 1 singular coffee filter. The pumpkin stress ball weighted 27.80 grams and the coffee filter 0.68 grams. So the total amount of time that it took for both objects to reach the ground was 2.5 seconds. The pumpkin reached the ground at 0.7 seconds with an acceleration of 9.28 meters per second squared. And the coffee filter reached the ground at 2.5 seconds with an acceleration of 0 meters per second squared. And because the acceleration of the singular coffee filter was 0, it is said that it reached terminal velocity.
Next, we added 6 more coffee filters to see if it would change the amount of time to reach the ground. The weight of the pumpkin was 27.8 grams, while the small stack of 7 coffee filters weighed 4.8 grams. As we have said, in the first trial, it took 2.5 seconds for the 1 coffee filter to reach the ground, while it only took the pumpkin 0.7 seconds. Once we added more coffee filter paper, the pumpkin still only took 0.7 seconds to reach the ground, while the pieces of coffee filter paper took substantially less time than before and only took 1.2 seconds to reach the ground. The acceleration for the pumpkin in the second trial was 9.4 meters per second squared, while the acceleration of the 7 coffee filters was 1.82 meters per second squared.
Okay, so the terminal velocity, when an object is falling, gravity pulls it down at about 9.8 meters per second squared, which causes the object to accelerate faster. Gravity and drag force affect a falling object. The terminal velocity is reached when gravity and drag force come to a balance, hence when the object touches the floor. Terminal velocity will be different for each object because of the way air resistance can act on an object based on shape and surface area. So the faster you go, the faster the drag will get. When terminal velocity is 0, it will equal the drag force. In this experiment, we do not see terminal velocity since the height from where the objects were dropped is very small. If we had dropped them from a higher height, then our data would reach 9.8 meters per second squared. So with air drag, the objects fell at different times and had different accelerations than we expected. The pumpkin stress ball was close to the expected acceleration, and the single coffee filter did not near the expected acceleration. And the 7 coffee filters had a high acceleration than the single, but it was still lower due to the drag force. And in conclusion, the pumpkin did not reach terminal velocity, but it was close to the 9.8 meters per second squared for acceleration. And the single coffee filter did reach terminal velocity as the acceleration is 0. In trial 2, the pumpkin did not reach the terminal velocity, but it was still close to the expected acceleration of 9.8 meters per second squared. And this coffee filters did not reach terminal velocity, and this is because the acceleration was not constant and not near 0. And the discrepancies for the trials was pumpkin 1 had a discrepancy of 5%. The 1 coffee filter was around 91%. The pumpkin in the second trial was 4%, and the 7 coffee filters was an 81%.